All right, let's try this. Class?
Yes.
All right, so for those people actually following along and pay attention, what page in my notes should be on?
17.
19.
19.
Jesus, giving me the wrong number. We just did 17 yesterday.
Okay, now, these notes right here are all part of one example. But I'm breaking it down. Each example is a different part of this problem that we're going to do. Okay? So, each part of every example is the same word problem, but it's broken up into different parts. So, write objective function describing quantity that must be maximized or minimized, inequalities, limitation to a situation, and these are referred to as linear programming. Okay? Linear programming. So, it's why we use the greater than, less than, all those, and with the more than one variable. Okay, that's what these are. Now, for this one right here, it says, writing an objective function. Bottled water medical supplies are to be shipped to victims of an earthquake by plane. Each container of bottled water will serve 10 people. Okay, starting with 10 people here. There you go. Each medical kit will aid 6 people. Let X represent the number of bottles. Okay. X represent the number of bottles of water to be shipped, and Y the number of medical kits. Write objective function that describes the number of people that can be helped. Now, this is going to be written as Z. Z is going to be the thing that we are going to number of people that are going to be helped. It is a variable that we're not normally using. So we're going to call it Z. So for every one case of water, how many people do we help? 10. It serves 10 people. It helps 10 people. So, and what variable do I use for every case of water? X. So it's going to be 10x. And this is, and then I'm also helping more people with the first aid. So how many people do I help for every first aid?
6.
6 for each one, right? And what variable do I use with that?
Y.
Very good, because I asked. See what I did there? You said why, and I said because I asked. Okay. All right, so this is a function. This is the objection function. This is where I'm solving to get the total number of people I'm going to help. Okay? Yeah. So that's the total number of people I'm going to help. So the next part is talking about a constraint. Okay? This is what we have here. We already have it set up here. And we're going to talk about constraints. Is a restriction and it is expressed as a linear inequality. List of constraints from a system of linear inequalities. So, think about this. What is the smallest number of people I could give water to? What's the smallest amount of water I could give? I can give less. 0. I can give people 0 water, right? Okay. So the x value has to be between 0 and some other constraint. Okay, I'm going to have some other constraint for that. Now, what about the y values? What's the smallest number of first aid kits I can give? 0. Okay, for the y values. So we're talking about, this is setting up my constraints for my x and y. So I know that my graph should start at 0 on both of these, right? Say yeah.
Yeah.
Okay, good. It's going to start at 0 on both of these, because I'm not dealing with negative numbers here. Now the next part here, it says, each plane can carry no more than 80,000 pounds. That's important. No more than 80,000 pounds. For each plane, no more than 80,000 pounds. So that's a limit. Can it be less than 80,000? Yeah, it can. The bottled water weighs, water weighs 20 pounds per container. Each medical kit weighs 10 pounds. What variable did I use for my water? X. So what number goes for each one of those is how much? It's going to be 20x plus. Now, how much does each medical kit weigh? So it's going to be 10y, right? It's 10 pounds for each medical kit. And so that's 10y. And all those together, when I add them, have to be less than, but can it be equal to? It can be equal to. So it's less than, equal to, how many?
80,000.
Very good. So 80,000 pounds. So this is actually based on my weight. This is based on weight. So now, have you guys ever moved a couch before? Okay, like from one house to the other, or actually just moving in general, right? Okay, you could put that couch in a vehicle. The vehicle will carry it, won't it?
Yeah.
But what's the constraints also on that? Will it fit? Will it fit in the vehicle? Yes, the vehicle can carry it, but will it fit in the vehicle? It's kind of like when you see all those riding people when like everyone was like stealing those giant TVs and they were like trying to put it in the trunk of their car and it didn't fit. That was you, right? Yes, right there with the phone. Okay. So, but you can see people driving down the road and they have a huge couch hanging out of the back of the truck, right? The truck will carry it, but it doesn't fit. So there is a constraint on size also. Not just weight, it's also size. So this right here is the same thing we just did. We just did this one. Okay, here's the programming because it's going to be Z people. Z people. Here it is. Example 3. Each plane can carry a total volume of supplies that does not exceed 6,000 cubic feet. That's a volume. Now I'm going to have a volume problem here. That means how much space do I have in the plane to fit everything? Each water bottle is 1 cubic feet. What variable goes along with water bottles? X. So it's going to be just 1x, right? Each medical kit also has a volume of 1 cubic feet. So that's going to be, because I'm adding the y now, and it cannot exceed 6,000 cubic feet. So can it be more than 6,000? No. It has to be less than or, very good, less than equal to 6,000. Right there, and that is my volume. So I'm going to have two different constraints on this. So I have a constraint on weight and a constraint on volume. So those are going to be what's going to affect all these. Okay? I'm going to have to deal within those two constraints there. And there we go, right there, same thing. Now, I have a system here. This is the system to solve for Z, which was the number of people. This is going to help, right? So this is what we have signed up, filled out already. So using this, I need to find what values are going to best suit this. So what do you think I should do with this system right here?
Plug in the calculator.
Yeah, let's plug it in the calculator and graph it. So we're plugging in a calculator and graphing it. And so since I'm going to graph it, I'm going to start here and I should dock B, right? Dock B to clear it. There we go. All right. So change it from a function to a relation. And it was 20x plus 10y is less than, okay. Now, to find those special symbols, it's control equal, right? Less than equal to There we go. Now, why does the whole thing come out blue?
Because we're not zoomed out far enough.
Yeah, we're not zoomed out far enough, right? We only see a tiny little thing. Okay, so let's go ahead and just enter our second one and see where we're at. I'm going to go with tab, and this was x plus y has to be less than equal to 6,000. Let's try that one. Okay, so now I know everyone's going to be taking notes because this is where we change our windows, right? Because a lot of people struggled with this last time we did it. So, changing the windows. Changing the windows. So, I'm going to go menu. What's after menu? Okay, window zoom. Hey, kind of recording my lesson, so can you come back later? Thank you. All right, so what do you think that X min should be? X min. Not X man, X min. What do we say the X min is? What's the smallest number of X values I could have? 0. Very good. Okay. And what do you think? What's the largest? What's the max?
80,000.
You want to try 80,000? Okay.
100,000.
80,000?
100. It has to be more. 90,000. Oh, you said the max.
Yeah, max would be 80,000. It's actually going to be less than that, so you'll see. Because remember, each one of these is a variable we're plugging in for x. So it is going to be less. So, but I'll show you. So I'm just using the biggest number. Now, what about y min? What's the smallest y value I'm going to use? 0. And what do you think y max? You want to try 6,000? Okay. Let's see if that works. Oh, hey. It's kind of there, right? But now, so you don't have to do too many crazy things. Is Dougie alive, or did he croak over and die? Okay. All right, so watch. This calculator is super neat. I'm going to put my hand down here on the axis. I'm going to click on it, and I'm going to move it. Now, am I up high enough for this graph? No, so I have to... Okay, so I'm going to do the same thing. I'm going to grab the axis. So hover over the axis. Get the hand, pull it down. There we go. And so now I have to adjust this one now. Why is that one not... Why are they both going at the same time? I didn't have that problem earlier. All right, so I guess it's high enough here so I could see that there. I gotta change this to a smaller number. I gotta change my X values to a smaller number. Menu, window zoom. I did the same problem earlier and it just didn't like me now. So let's change that to 0. Change that one to, I don't know, 6,000. Zero. Let's go 6,000 again. Hey, look, that's better. So I changed my maxes to 6,000. And so now it fits a little bit better, doesn't it? So we're going to have to go through and graph. So we got to find some values. Now, where my answers work out, how do I find my answer for these? What part part is my answer? The overlapping colors, right? So in this case, it's that magenta or the violet, right? So the overlapping colors are right here in the middle. So I gotta find some points right here for this. So let's go through and find some points. Mishak, are you all right? Okay, so I'm gonna go menu, analyze, intersection. So that's gonna give me this intersection point right there. Now the next thing is kind of new. We haven't done this one before, so I want you to watch closely on this next one. So if you notice the violet right here, or this magenta in the middle, I gotta find where it touches right here. So I'm gonna tell my calculator I want to trace. Menu, trace, graph. Okay? So now all I have to do is arrow over. And when is it on? Hey, look, there it is right there. So that point right there is...
I don't know, mine says 3 something too. I'm doing it wrong.
Okay. Are we okay or no? No, what's going on here?
Ours says like 2E or 2E plus
3E plus 3, 2E plus 3. For the,
All right, so you did the trace like I did, right?
and then for the intersection point, it also says 2E plus 3 and 4E.
Oh, okay. So, okay, I know what's wrong. Right here, go here, menu, settings, float, 7. Menu, settings, float, 7. Because you're like on float 3 or something like that.
Yeah.
And then hit OK, and then now you can see those numbers. Are we okay or no? No? Still no? Luke? 4K. What happened? What you got, Luke? Ah. Oh man, you got to start at the beginning. Okay, start by entering the function that we did right there. Okay, so it is that one right there. That's one right. You need to battery. Tab. Okay, you got them there. Okay, so let me see. So let's go menu, window, okay, settings. It should be 0. You take this 6,000. Battery okay, menu, window, settings.
Yes.
Zero. 6,000. 0. 6,000.
There you go.
Okay. Alrighty. Paige, you guys get it now?
Kind of.
Yeah?
Yeah.
Is that a hand or no? Okay. Like you're. Can I get a witness? Right there. Right? Yeah. All right. Preach. All right. So now we still have to find the other points. I got to find the other points where it is the magenta color in the middle, right? So I need to try and figure out right here where the point is on the axis. So I got to do that again. Menu, trace, graph. Now, I don't want to trace the blue one again. I want to trace the red one. So I hit arrow up. Now it's on the red one.
Oh.
Yep.
It's the same number.
And so I'm going to just follow it over. I'm trying to find where this actually is on the axes.
Oh.
And what did we come up with? We came up with 6,000. Now, there's one more point that should be on here. What is the smallest value I could use? 0. So, isn't this also... I also have this one as a point. So I have 1, 2, 3, 4 points that's going to box that in. Does that make sense? Yes? So let's go ahead and take a look at what we have here. So I am trying to get, I have this point to here, over and up. So all this right here will work for my solutions. All those right there will work for my solutions, right? Now, I'm going to check all the points. I'm going to check it. These are the points or the corners for my z value. Remember, my function for z value is the number of people that I'm going to help. Is going to be, what was it, 10x plus 6y? Okay. So this is for my number of people I'm helping, right? Remember, z is the people I'm helping. I want to maximize the number of people I can help. Yes? We're trying to maximize that. So I want to have the largest number I can get. So my points that I'm going to use are going to be at, let me see, I have that point right there, which is 0, 6,000. I have another point, which is going to be 2,000, 4,000. Another point, which is 4,000, 0. And my last point, which boxes that in, is 0, 0. So that's using all my constraints. So I just connected all the dots right there, and now I have that little boxed in area. Now we have to test it to see what's going to work. So I'm going to use these right here into my formula. So my z equals, now 10. Now my first value was 0, wasn't it? 0 plus 6, and my y values were 6,000. Equals. So now I want to maximize the number of people I'm going to help. So I want this z value to be the largest. So plug this into your Scratchpad. You don't have to have it on the graph. You could just plug it into the regular Scratchpad. So I'm waiting for some people to wake up and put their calculator in their hand. Sup, Dougie? You can't pretend like you're doing something without the calculator in your hand. And it's not a phone. Yes, it has Wi-Fi, but don't try to make any calls. So, this value right here gives me how much?
36,000.
Very good. 36,000. And that's 36,000 people that I'm helping, right? Good. The next one. What was the next point? 2,000 plus 6 times. All I'm doing is plugging in my x and my y to my optimization for here. $44? Next one. What was this one? 4,000? Plus 6 times 0? Like that? Okay. We have 40,000 there. And my last point, which I should always check anyway,
0.
0, 0. So 10 times 0. Now, my optimization. What is the maximum amount of people I can help with this? Very good, 44,000. So that means that is the optimal. That is my optimal solution. So that means that when I have 2,000 water, and 4,000 first aid, is it AID, ADE? Okay. That is the max amount of people I could actually help with this. This is actually a real world example of how you do these inequalities. How you could optimize and you have these systems for fighting these. Now for this, what was key to actually doing this? Kind of your calculator, right? But when you read through this, what did I emphasize every single time as we got new information? The variables that go along with it, right? So I had the volume problem set up and I had to deal with the variables. I had the weight problem set up and I had to deal with the variables. Okay? Those are important. That's where you're trying to get at. So this is right here. And I believe that's it, because it has the same thing on the next page right here, where this one is the maximum. That's it. So, it's not too bad, right?
No.
Okay, so I'm going to make this one a very short lesson or short homework here for you. So make sure you guys all like, share, and subscribe, hit that notification button, and support my channel. Buy my merch.